Okay, thank you, Shreyash. Now we may formally begin the session. I'll request the volunteers to kindly start recording and start the live stream so that we can begin.
Yes. So good morning, everyone. Good evening, everyone. A very warm welcome to very first session of Space Architecture.
Wait, let's just record and start streaming and then we can proceed.
Okay.
Yeah, so that the students who are live with us on YouTube do not miss your impressive introduction.
Okay.
Yes, Harshvardhan, you can proceed.
Okay.
Good evening, everyone. Very warm welcome to very first session of Space Architecture. I'm Harshvardhan Brande, NASA HQ volunteer. First of all, I would like to congratulate you all for being selected for this course. Before we begin our learning session, I would request Abhinay Ravichandran, Events Head, NASA India, to say a few words.
Thank you, Harsh, for this opportunity. A very warm welcome to all our lovely participants. Congratulations on getting selected to take part in NASA India's Winter School program, Space Architecture, in collaboration with ARCA Space Studio. I welcome on board Asta Kacha ma'am, who's doing a wonderful job traversing into this up-and-coming field of space architecture. We're happy to have you as our tutor, ma'am. With NASA India's Winter School program, we have tried to curate courses that are not ideally taught in architecture schools in India. Hence, I hope all of you have something new and exciting to learn from this course and have a delightful time doing so. There's a lot of scope for exploration into space architecture. Even the sheer thought of it is so fascinating to me. So I hope all of you have an out-of-the-world learning experience through this program. The future is here. Thank you.
Thank you, Abhinaya. Now I would request tutor of the session, Asta Kacha. ARCA Space Studio is founded by award-winning space architect Asta Kacha, who is 3 times TEDx speaker, technologist, and philanthropist. ARCA is an evolving international design practice with a core focus to design, build, and test prototypes based on interactive human-centered environments for extreme climatic conditions, space missions, lunar and Mars missions. To know more about their work, please visit www.arcaSpaceStudio.com. I hope you all enjoy and learn a lot from this course. Thank you, ma'am, for joining us. We welcome you to the platform. Over to you.
Good evening, everyone. First of all, thank you so much to NASA India for inviting me. And I am so excited because this is not India's, but Asia's first ever space architecture crash course going on. So I'm so excited and I feel so honored to spread this knowledge that I have. And with this, I will start with my journey. In my previous interviews, and so many times I'm often asked that what inspires you? Why are you into space architecture? How are you even going to go to the moon? It's such a far away dream. Why are you pursuing this thing? So this is a very lifelong vision that I have been holding myself since I was 13 years old. When I was 13, I went to this NASA Space Academy at Huntsville, Alabama Center. And over there, we were given a lot of different tasks. But one of the challenging one was to build something on the lunar base. And we designed a fuel station because we thought that we might run out of the fuel while we come back to the Earth. And we got an award for that. So in that moment, I realized that, oh, I'm so good at this skill maybe, or at designing something out of the world. So maybe I should pursue this career. And maybe I would call myself a space architect, an architect who designs out of the Earth. But then at that time, there was not a single discipline such as this. So I thought I will study architecture technology, and then I will study some space subjects, and then I will have my own space architecture career. By the time I got graduated from VIA University in Denmark, I realized that there is actually a professional career for space architecture. And that is how I began my journey. I presented my first project at a NASA conference, and my project was judged by astronaut Daniel Burbank. And it was such a event that everybody in that conference was from space background except myself. I was the only one who was from architectural background, and still having a good response for my project motivated me to pursue and work more into that. So sometimes it is okay to do something which is never done before, which someone has never done it. And first step is very challenging, but once you start taking after that, it's all the blocks are coming together. So let me share my PowerPoint presentation and we start with this course. I hope all of you can see my screen.
Yes, ma'am.
I hope you guys are excited because we received over 1K applications and it was very, very challenging to select only 55 students out of that. And yes, it's just such an exciting thing. So this is some of the glimpse from my journey that I was at the NASA Academy. I am so much looking forward to teaching this course because this is actually a glimpse of our 1 month and 6 month of training program that we are going to start from the next month at ACA. We will start with introduction to space architecture because it is very much important to give you the knowledge on what exactly space architecture is and what are the different industries are involved into that. And then how space architecture is going to be such a crucial subject in the coming years. And also it is going to be an emerging discipline in India in less than 3 years from now. Following that, we will talk about how does a space architect approach a project? How do we analyze a mission that we are going to pursue? Or how do we do the design analysis for a space mission? Then I will take you through TRL and HRL. TRL is technology readiness level and HRL is habitat readiness level. Over there, I will show you the different spectrums that we need to perceive to accommodate our goal into space architects project. And then we are going to go in a little bit of detail to different types of habitats. So basically there are a lot of different types of habitats which are considered into space architecture. Let's say, for example, extreme environment habitats, habitat in Antarctica, habitat in Arctic, underwater habitats. These are all habitat in a desert. These are all a part of space architecture. Then habitation on lunar surface, on the Martian surface, suborbital, cislunar orbits. This is all space architecture. And then we have a very, very interesting thing that is called Design Studio Session 1 and Session 2, where we are actually going to learn on how do we design a space habitat. So we will start with habitat system research, like what kind of systems do we need, how our habitat will be functioning, what will be the role of the crew living in that habitat, is that habitat for the moon, for the Mars, for the orbit, for what? And then we will go into the conceptual design and habitat design. So we will define our goal into depth and then we will come with a conclusion of our project. Following that, we have a very easy to go session, which is called Disciplines in Space Architecture, because space architecture is not just about architecture or someone coming with a design thinking background, but it also includes a lot of different disciplines, such as sociology, psychology, physiology, engineering, aerospace engineering, space engineering. There are a lot of different subjects which are all combined together, and then one project is being built. That is a space architecture project. And then we have this space folio. This is I believe that it is theory work is not everything. Theory is one thing. Then we have to do a lot of implement that theory into our design. So we are going to have these theory sessions and also practical sessions. And then at ACA, we really believe at its core that when you don't build it, it's just going to stay in the paper. So important is for us to also build it. So, but because we have limited amount of time to pursue this course, so we will just stick with the space folio, where we will total have 18 teams, and 9 teams will be performing on 8th session and 9 teams will be performing in the 9th session. And then we will have a competition. We would have a winner for that. And we have very amazing plans for the winning teams. And each team will be a member of, we would have 3 to 4 members fine per team. By the end of this workshop, you will be able to at least have an idea on how to start an approach when we design a space habitat. So I hope you will all enjoy. It is not that complicated. We have tried to summarize this course as much as in easy language as possible. So how did this ACA basically started? Let me tell you that ACA is India's and Asia's first space architecture firm. In the world now, there are not many space architecture firms that exist. In the US, in Canada, it is very common, these things. Also in Europe, it is coming now. But in Asia, this is very rare thing which is happening. And how did it all started? So I was born in India, and I was not able to get enough opportunities into the space sector while I was in and the West while I was in US and Canada, because for that I had to be a US citizen, and that restricted me to gain more opportunities. So after presenting 2-3 projects all over the world, I thought, why not I just take this initiative and start my own firm. I just need to make a comment over here because I think my teammate is sitting in the next room and it's so loud. Maybe Vadim, you can turn down your volume in your laptop. It's super loud. I hear my own voice. Sorry for the interruption. Thank you. Okay, so moving back. So how did this all started? See, there is always more than one way to climb to the top of the mountain. And when there are no opportunities, you create them. I'm very much optimistic about the vision that I have. And I feel like we all should be very optimistic. So this is a slide for me. So after the first person I talked to is Vadim. You can see he's also in our today's session. We both studied from the same university. And I was just randomly sitting and I was talking with him that if I do something like this, like what if you're designing for the space? Would you be interested into this thing? And he was like, yes, why not? Let's give it a try. And that's how we both talked to our more friends. And together we all came together to form this ACA. And initially we were all volunteering and we were all at the different parts of the world. So Vadim used to be in Denmark, other teammate used to be in Ireland, I was in US. And we had some teammates from India and we were all working on this thing for a year. And now we have come to a very good state. So what do we exactly do? And we basically start every project from the scratch. We start with research and development. Then we define a problem. What exactly is the problem? For example, let's say that we want to design an orbital structure. Current example of orbital structure is International Space Station. So what is the problem right now in the space? First of all, it is not affordable because it is so expensive. We have a lack of infrastructure development in the space right now with commercialization taking place. So we define the problem. Then we do the mission analysis. Following by that, we do our conceptual design. Then we do a very tentative model. And we mostly use Rhino Grasshopper at our studio. And following that, we do a various analysis. We do analysis in ANSYS, NASTRA, we do the structural, mechanical, aerospace, aerodynamics, thermal. And then we conclude all of that our research and we aim to build a small prototype. So basically, we solve challenging problems with a very perceptive approach by doing research. We work in a very collaborative work environment, and then we make sure that we are integrating the latest technology that is coming up. Just today, we have achieved VR for space. We developed our whole architectural project on Mars through VR. So anyone can have an experience what does an habitat on Mars looks like through a VR experience. So we are a growing architectural firm, and it is also very important to give back to the community and not just consume. And so we also believe in solving the challenging problems on the terrestrial surface. For example, now there are so many issues on climate change going on. So what do we do? Do we achieve zero energy design? Do we consider more sustainability into our projects? And we also solve affordable housing and things like that. This is a very interesting project that we have been working on, basically, NOVA. It is a next generation origami architectural habitat. So right now, for the space, most of the habitats are based on inflatable structures. Inflatable structures are like a balloon. So you blow up a balloon and then we pressurize the balloon with the air and it expands in the volume. Now, one of the crucial thing is, when we are launching anything into a space vehicle, we have to make sure that the weight, which is payload, is always as light as possible. And when it is deployed into the space, it expands in its volume because that will help us to save the cost. So I did a very intensive research, 3 years of research on what is the other alternative to inflatable structures, because inflatable structures, you have to constantly pressurize that with air. It can blow up. It has to be constantly maintained. It cannot be repaired. And I came up with this whole new concept. Why not we use this origami? Origami is basically the paper folding technique that we used to play. We used to have these classes in our art class when we were studying. So NOVA is a deployable origami structure, which is a settlement, which is a project between the permanent settlement and primary settlement on the Mars. So, to explain in a more simple words, now, when Apollo mission took place, the lunar module landed, it descended from the main module, okay? And in the lunar module, astronaut Buzz Aldrin, Neil Armstrong, they both stayed in. And that module also had a toilet. It also had a small galley, which is like a kitchen, and then a sleeping quarter, all of those things. It was like a mini habitat. But we cannot live in that small amount of space when we are going for a longer mission, for example, a mission for 6 months or 8 months or a year, because it's a very small space. And to build a permanent something on extraterrestrial surface, we need to use a 3D printing, or we need to use resources which are already available on extraterrestrial surface. For example, we are also doing this ISRU. It is Lunar Regolith 3D printed research. And that will also take time. So what do we do? So this is a deployable structure which can be easily deployed from the existing structure, and it can sustain for 6 months to 1 year. And the fun part of this project is we are into our analysis phase right now. We are going to construct this, and we are going to take this project to Arctic in a very, very north place. I will not disclose too much of information. And then we are going to do a 3 month of an expedition, whereas I myself is going to stay in this habitat. And we are going to perform various scientific experiments. We are going to check the deployability, how long does it take to deploy the structure over here versus in a reduced gravity. We will be performing a lot of extravehicular activities and things like that. Then we have, so again, I want to tell all of you, because you guys will be working in the team, because you will also be developing your own project throughout this our course, I really want you to focus on this thing, that how do we approach our projects. So we start with the mission analysis. For example, we have to define how long our project is for. I will talk in detail in the coming sessions. Identifying problem. Then we define the challenges. What are the challenges? For example, let's say we want to design for low Earth orbit. Then we have a vacuum, we have the radiation, we have the pressure difference, we don't have the oxygen. So there are a lot of challenges that comes. Then we do the design analysis. We scrap through the books and we find out how do we design if there is this kind of situation or that kind of situation. Then we do the engineering analysis. Then we see the resource. How many resources do we have available with us to build such a structure like that? Because costing and affordability plays a very crucial role. The cheaper the project, the more times it can happen. And then we do the prototyping and building, which we are going to do for this project. Following that, this is my first project, Mangala. I don't know how many of you had a chance to go through my LinkedIn, but I have a lot of details about this project on my LinkedIn. This is a 3D printed Martian habitat. And this has been 3D printed using basalt fiber, which is a composite of a Martian soil. And this is around a 6.5 meter in diameter. And I had 3 floors into this. They were also all 3D printed. And inside I had a pre-modular furniture. We don't have technical drawings for this on this presentation. But I had designed in the basement sleeping quarters. On the ground floor, I had a medical emergency lab, a greenhouse. Then I had a chemistry and bio lab. Then we had a small kitchen. And on the top, we had a communication room. There are a lot of this. You might see that it looks very good on the render, but reality is not that. Render is 0.5% of what the project is. So there is a lot of technicality into that. Then we have this Torby. This is also a deployable origami structure, and this can also be folded and unfolded, and it can also be modularized with many of that, and they all can be docked together, maybe something like that. Yes. And this is based on the Pressling pattern. Now we designed this considering the Elon Musk's SN15 Starship. You might be aware that I think you all must be aware how Elon Musk is into the space sector and how his SpaceX is developing. And recently, for those who are not aware, SpaceX SN15 Starship was approved to be used in the Artemis mission as a lander, as a lunar lander. So that ship will be carrying all the cargo from the Earth to the moon. And so whenever now at ACA we are designing a space habitat and we think that we are going to deploy it from the Earth's surface, we make sure that we are considering SN15's volume, payload, and the diameter and height and width consideration. So what exactly is space architecture? As I mentioned earlier, space architecture is a theory and practice of designing and building inhabited environments in the outer space. It is a very architectural approach towards spacecraft design that addresses the total built environment. Now, to say this in very simple words, anything that goes outside of the space, and when the crew, means there is a human inside of it, it requires space architecture. And when we design for the space, we calculate everything in terms of the volume and not in feet and inches or meter much. We calculate in volume because our body reacts very differently when we're in the reduced gravity or in the vacuum of space, because we have a different hands and legs movements. And some of the examples of space architecture existing is this one: International Space Station, then SpaceX Dragon module, Apollo lunar module, and so and so. There are a lot of topics included into space architecture. Space vehicles are also a space architecture. Space stations, planetary habitats, Earth analog for space applications, simulation and test facilities, habitats in Antarctic. There are so many research centers in Antarctic now. There is a Russian Vostok station, there is a Bharti station, and there are many more. Then habitats in Antarctic, airborne habitats, desert habitats. And for example, let's say that there's a Sahara Desert, and if we even a resort designed in a Sahara Desert is indirectly an example of space architecture because it falls under the extreme environment category. Then we have high altitude habitats, underground habitats, even undersea habitats, and also very closed ecological system habitats. This is all space architecture. I think by now you must be aware that there is already existing infrastructure on the Earth which relates to space architecture. So this is not something which is very new. It has already been existing, but now that we are able to recognize as a whole new, total different subject, because there is so much to study and to look into it. Then we have space architecture as a discipline. Now, in space architecture, there are two main disciplines that plays a very crucial role. One is the architectural and one is the engineering. And we define these parameters on the four different things. One is the problem definition. Problem definition as in for example, in engineering, what will be the end product? That is what engineering approach does. For architecture, what is the process? You might be aware that when we are designing any conceptual project, even when we are designing for the Earth, then we also do this design process, sketches, conceptual process, drawings. So architecture is more of a process. Then in the engineering, we have a linear analysis. In architecture, we have a non-linear analysis. Then in engineering, we have the workflow from the start to the finish with the numbers. We have a very quantitative method. And in the architecture, we look more over to the quality. So we have more of a quality method. In engineering, there is only one ideal solution. But in architecture, there are many. Even in the real world, I'm not aware how many of you have experience working in an actual firm, but our architect's mind is like we design out of the world things. We want to have a window like that. We want to have a balcony like that. We want this kind of a furniture, but in actually it is not all the time possible. When a structural engineer also starts evaluating our design, that's when we know that, hey, this is not possible. You cannot have that column lying at 3 floors of a height with no slab in the middle. It will fall the structure. You cannot have that big canopy. So it is a mixture of both. And it is very relatively new, as I mentioned. Now, space architecture as a whole. When we define the space missions or any of the missions in Antarctica, they can be categorized into 3 different things. First of all, short missions. Short missions are like also, if I talk to you about on Earth, then expeditions, like a camping in the snow, it also like a short mission. We have a medium-sized mission, which is from 6 to 12 months, and we have a long-term missions. Then, when we design a space project, when we do the mission analysis, there are a lot of ways, lot of things to consider before we start on our project. By the end of today's session, I will also take you through, maybe I think I will take you to that tomorrow. That is, tomorrow in the session, I'm going to teach you in detail how exactly we do the mission analysis. So first we have to define what is the duration. Because the duration of the project will give us the life cycle of the project. Now I did my education from abroad, so I'm not aware if we have life cycle costing in India or not. But every project needs to have a lifespan. Mostly architecture projects span from around 100 to 150 years if they are built using the good cement and everything. So also for the space, because those are very expensive, it is very important to define how long we want to sustain our project, and that is why we need to know the duration of our project. Then distance from the Earth. What will be the crew size? Now, when we are in the space, okay, everything is calculated. The amount of sweat that you will have, it is also calculated. Every drop of perspiration is calculated. Every ounce and pound of the food that you will consume is calculated. Everything for the space is calculated. And when we increase the crew size, also we have to increase a lot of resources along with that side by side. And that will increase the cost. So this is all is very important, that if we are designing for the three crew size of a 3, and it is only capable, especially for the space, that it will only sustain for the crew size of the 3. We cannot just in the last moment say, oh, now 4 people will go because I think we can accommodate. That is not possible for the space. Then also degree of isolation. Now, have you ever seen, have you ever observed, you have a room with no windows, how would you feel? And you have a room with windows, with a very bright floor-to-floor height of windows. You will feel more happier, you will be able to see, you will be a factor. That plays a very important role. And the farther we go, the more isolation we have. It is so, when most of you are studying this bachelor's project, when you are in your final year of architecture, you are that one isolated person from your rest of your friends. In that period of time, how you go through the isolation, the amount of isolation that a crew faces when they're outside of the Earth is 1,000 times more. They also have this homesickness because they are far away from the Earth's atmosphere and the comfortability. And that's where the space architecture plays a very crucial role, because our primary job is to make sure that the crew is safe, mentally sound, and his well-being is up to the standard and is well, because his successful health will help us to implement our mission. So, and there are huge costs involved after this. So interior design of the space habitat is very crucial. Then how do we evacuate in emergency? That is also very important. Also not aware how it is in India, but when I was studying abroad, we used to make these fire plans. We would always have these fire plans. In case of fire, how do you escape? I think here also I've seen in some of the buildings. That is also very important. Then are we going to outside monitor? Yes, no. Two-way communication are we going to have? Of course, yes. Then would we have internet access? Visitors, we're not going to have any visitors in the space other than low Earth orbit structures. So there are a lot of aspects that we have to consider before we start on to designing a space habitat. And the longer and the more isolated the mission is, we need more of the qualitative design. And habitat layout plays a very crucial role, where you arrange your sleeping quarters for the crew, where you are you going to design a common living space for the crew, are you going to design entertainment room, a fitness room? All of this plays a very important role. By the way, let me tell you, International Space Station, we do have a gym. And then the longer and the farther away from the Earth, the more sustainable the habitat has to be. And also self-sufficient. Now, for example, let's say that we designed a habitat on the lunar surface. Then I'll just quickly go and grab my charger. I think it's gonna die. Oh, sorry, give me 1 second. Start sharing my screen. Window, maybe. Back, share, window. And so this all plays a very important role. Now, for example, if we...
Your screen is not visible.
Oh, okay. Let me try again.
Yes, ma'am.
Entire screen. Window. Is it visible now?
Yes, ma'am, it is.
Okay. From current. Now, when something goes wrong over here, it is so easy to just repair it, change it. But it is very challenging when we are in the space. So we have to make sure that if something is destroyed in the habitat, it is possible to replace it very easily. And that is why origami plays a very crucial role, because let's say, for example, a panel is damaged, then it is very possible to 3D print that panel and fix it back into the structure. Space industry is at a boom right now. In West, this year, there are going to be 9 countries landing on the moon. Space is coming because the thing is, space is so exciting to me. I'm just trying to put the right words. Space is something which is the next thing happening, because with the climate change and everything happening all over the earth, space is something which is our next very much step to continue the human species. This might look very out of the world topic because I think you are getting familiar with the subject, but our science and our technology has been very much advanced already right now, that it is not being publicly displayed out right now. But space is coming at a very big boom, and it is going to come at a very fast rate in the next 5 to 10 years in India. You might be aware of this Gaganyaan mission which is going to take place. Also in Bangalore, we are developing our own astronaut training center, which is India's first astronaut training center. They also recently selected a woman to participate into that. So it is coming, and it is not a faraway dream now. This is, and even at this, because see, we are a startup. When we are a startup, we apply for this government grants. We get the funding from the government, from the institutions. And what I personally have observed throughout my journey of starting ACA, there are so many space grants available these days, and there is so much funding also available. So this is a very big boom coming. And these are the references that you can go through the slides. I think this session is being recorded, so maybe I will just hold on here for 2 minutes for anyone who wants to have a reference on where we got some of our information from. Okay. I'm going to now stop sharing this, and I'm going to share something else. So as I mentioned earlier, that by the end of this session, we have this very interesting space folio, and everybody in the team can start working in a space folio from now itself. So I'm going to show you how do you form your team and what you have to present, and what you will be presenting in the 8th and the 9th session. Every lecture into this course will help you to take you one step closer to that end project. I'll just go back and share my screen. Entire screen, share. So I created this, okay. I know that you all are very new and you are all trying to know each other. So I'm going to give a try for you to develop your own teams. If you're not able to, then by the end of in 2 days, we will develop your teams. But I really want you guys to get to know each other in the group, try to know each other's skills, and form your own team. So here we have like 18 teams. I think because we have 55 students, one team will have 4 members. Gather your team, find your team, get an amazing team name. For example, you can have Mars X, Moon Y, whatever you want to give a space name, tech name. Please put your full name over here, team member 1, team member 2, and team member 3. And then you need to put your spaceful topic on what project you actually want to work on throughout this course. Let me be very honest. This is a very big opportunity because I personally will be helping every team to develop their project. Anywhere they are struggling with the software or the information or the design thinking, I am going to help personally to every team. And anyone after this course who wants to pursue further their masters into space engineering or aerospace engineering or want to go into the space sector and become a space architect, this Spacefully will help you a lot because this will add up to your experience and to your portfolio. So give your best shot. And I'm gonna go back again and share my screen. Share. So I'm going to share this drive with all of you. Maybe I can just share here. Share. Maybe I think I will send in that our WhatsApp group. So we have 2 folders over here. One is the space folio and one is the reference materials. In the reference materials, I have provided the minimum, and I think the books that will literally help you to develop your project. These are some of the very private books that we have been using at our studio, and we are sharing it over here. This is a very important book, which is basically the encyclopedia of everything for space architecture. It is called Human Integration Design Handbook. And in this book, see, one more thing. I know this is a very challenging subject that you have. First of all, be very proud of yourself of coming to this workshop, because not many would have that courage to participate in such a workshop. So there will be many things that you will not know, and it is okay to not know. And if you are going through a book and if you don't understand anything, just feel free to send a message to our WhatsApp group and someone from our team would answer that. So don't hesitate at all, or don't step back if you don't understand some terms out of that. We all started from somewhere, and my whole team, we were not any of us from space background when we initially started, and we all studied through our way. So it is a ongoing process. And in this book, you can exactly know how exactly the human body works in space, how much height, width, and the volume you will need when a crew is wearing a spacesuit, how they will have the momentum around, what is the anthropometry, because it's very different for space, how is the range of the motion. So you will have in the chapter 4 is very important. You can have a very detailed understanding of how to design the space requirement in a space habitat in no gravity or reduced gravity. Then we have human performance capabilities on how does the crew performs in International Space Station, like the psychological factors, how is their visual, cognitive. Then we have what kind of environment we need in a space habitat. For example, how should be the internal atmosphere, how should be the water recycling, contamination, acoustics, vibration. And this 7th chapter is my most favorite one because it's exactly the habitability function. Now, when we design a space habitat, it is not super different from a normal architecture, because even in a space habitat, we need to have a kitchen, a toilet. In the toilet, we need to also have the sink. In the kitchen, we also need to have the storage, sleeping quarters, some privacy, some mission system requirements. And then we will also have the windows, sanitization, recycling system. There are a lot of similar things, but they're just a little bit different for the space. So in the habitability function, we would have food and nutrition, what kind of food and nutrition they have, how do we store that, what are the kitchen requirements or the galley requirements we need for that. Then we have a body waste management, how our perspiration is recycled, how our sewage waste is recycled, all of that information. How does the medical look like, storage, how does the sleeping should be like, clothing, housekeeping, recreation. And then there is this 8th chapter. So this book will give you the basics on how to approach and start with the design thinking. Then in the architecture, we have this, the introduction. Overall, the architectural design, how it should be, what shapes to use. There are, personally, we should always go with a circular shape because the air pressure is circulated equally when we go with a sphere or that kind of a shape. Because when we have the more corners, air pressure is not distributed equally. So especially when our habitat is inflatable, we need to go with a circular or that kind of a shape. Then what is the location, lighting, what kind of lightings we should have. By the way, if anyone wants to do a very detailed in-depth for lighting of a space habitat, please reach out to Vadim because he has done his master's in lighting design for space. Then we have hardware and equipment, what kind of hardware we would need, because it is a very complex mechanical and hardware system when we design a space habitat. And it also depends from mission to mission. And then we have this crew interfaces. So basically, what kind of system? This is also like what kind of systems we would need. This is okay. This is also okay. But the most important chapters for this book is chapter number 8 and 7 and 6. This is very important if you want to have a really very good project by the end of this session. This is the first book that I had started my space architecture journey from, so it's very special to me. Then we have also uploaded International Space Station. Now in this book, you get to know everything about how does the International Space Station works, what is the architecture, because International Space Station is the most prominent example of space architecture. So here we have, you can see all of the different models of ISS. I will just quickly glance through it and stop by what is important. So from, I think here it starts, maybe a little bit more down. Systems. This is all okay, I think. We must have an index for. So the construction equipment for the ISS station is chapter 4 is pretty much important, and then we have day in the life in-flight maintenance. But I believe that there is also one more book. I think Sautik, are you here in this call? Maybe I will request you to also upload the International Space Station book that we have been working on previously.
Yeah, sure.
In the library, please. Okay, so we would have one more book which has all the architectural design and everything for ISS. Then we have this one for Mars Habitat. If anyone is going to work on the Mars Habitat project, then this is your go to start with. This is also one of the project. I will let you guys go in detail whenever you have time. Go through this just in the next 2-3 days and come back with the questions. You will also find many resources on the web, so it is all available. You can see some different types of Martian architecture. We have a very interesting advisor on our board who happens to be one of the first few people to design a Martian habitat at a NASA. And this book is referenced by him. So you can see a lot of details in this. Then we have also this one, Lunar Architecture. If anyone is going to pursue for moon architecture, then this is it. This one also has a lot of information. So I uploaded some of reference materials here. This is surviving in the space. Okay, now going back to Space Folio. Maybe I think it's better I share the screen only. I share my link, get link. copy. And then so all of you can open on the back. Okay, I think you should be able to access to this folder. Now when you go to space
Access is denied for the folder.
Okay, let me try again. I think I need to give permission. Anyone in this group with the link can edit, change. Anyone with the link? Okay. I think now it should be working. Is it working?
You need to copy that link, that update link.
Oh yes.
Oh, no man, the previous link is working. I am able to access it.
Okay, nice. Still, for the sake, I'll send one more thing. Okay. Now, the most important and interesting part of the session, space folio. Now, when we go here, there is a detailed delivery brief. You can always book an appointment with me or any of my teammates. This is a special thing that we are giving to NASA India. Okay, so you basically have 4 choices. Either you can go with a planetary habitat, for example, a lunar habitat or a Martian habitat or anything. If you want to go on Venus or Saturn, but I suggest not to go with. Probably stick with a lunar habitat because that is. I will tell you something. I have 2 of my friends who are actually involved in building a habitat on the moon via NASA and 2 big companies collaboration. So you can go with I personally recommend that go with something with Lunar Architecture because that is a very close dream. Then we have this extreme environment habitat. Here you can choose either underground, under sea, anything on the mountain or anything in a where there's a earthquake possibility, extreme environment, you can go with that. Then you have orbital structures, low Earth orbit, cislunar orbit, lunar orbit, Mars orbital structures. There can be various types. Then we have this algorithmic computational design. In our studio, one of the things that plays extremely crucial role is this computational design. Because when we are aware of how this computational design works, we are able to perform stimulation. And in simulations, it helps us to identify the problem at a very early state. So this is so important. So when we were doing this origami structures, when we were working on the NOAA project, we did the grasshopper coding, and then it was so easy for us to increase the number of the folds, the mountain folds or the valley folds, or however we want to deploy the structure. Computational design plays a very, very crucial role, and it is a lot coming into the industry. I'm not so sure how much it is being performed over here at the architecture firms, but Rhino Grasshopper is something that I really recommended everyone learning that. It's very important. And then, so you have a choice to select any of these 4. It totally depends up to your team. I really have this question on how you will start with forming your team. Maybe you can maybe someone can put a tag that anyone interested in orbital structure and then see how many responses are there and then form a team and maybe try something like that. Someone has to be a leader. So I will be very much looking forward on who is initiating this team formation in your group. Then we have this thing in the delivery brief, what you need to present. So we have basically general requirements. Actively listen to the lectures, which is a must. Then discuss with your team, design and be creative. When we will evaluate your project, it will be based on not what is your end output. It will be based on what is your creative approach towards your design. How are you approaching the project? How have you researched? How much have you researched into that? How are you evaluating your design? How it is going to change something which has never done before. This is all very important to us. You're thinking basically. So, and I suggest that when more minds come together, that's when we're able to perform miracles. So sit with your team. It's very interesting. then follow up with the given resources and the lectures. Right now we have uploaded these materials. In the coming sessions, we will be also uploading more and more as and when required. Then in the planetary habitat for the design brief, we have to first define your objective. Objective as in, what is your objective? What kind of project you want? Then you have to choose a location. Let me tell you, even if you're designing on the moon or on the Mars, you still need to have a location. I will give you a hint. For those who are planning to design on Mars, Jezero crater is something which is the next possible human crew landing which is going to take place. When we choose a site on a extraplanetary surface, we have to also study a lot of factors. For example, topography for the landing. Is it possible to land a module, or how is the surface? Then resources available near to that landing. For example, is there a water element near to side? Is the soil, are we able to use that soil and form a composite for 3D printing? There are a lot of things that also takes place when we are choosing a site. Selection of a site is a very crucial thing. And I suggest that going through a lot of NASA's previous moon Apollo landing site for your reference, because that will help you a lot. And now a lot of, also you can, I think NASA's website is your go-to-go, because on that you will find a lot of also topographic maps with the temperature difference, pressure difference, all of that information. So go for it. This is super interesting things. Then we have this thing, identify the challenges. Now, when you have a location, what are your challenges when you're in the space? So think in a group, come up with that. Then we have research possible solutions. Develop the mission concept. Then we have orbital structures. In the orbital structure, you have to choose the goal of a mission. Now, I want to tell you, space debris is a very big challenge right now in the space. It is such a big problem. Anyone who is able to come up with a solution on how we can collect space debris and recycle, maybe not even recycle, at least collect them, pick up them. Collecting a space debris, preparing a structure for that in space is also space architecture. So go with such projects, because that is, we should also try to solve the problems and the challenges which are already existing in the space. We cannot just create the whole garbage that we have created on the Earth and do the same thing that we are doing on the Earth. Do that also in the space and also on the Mars and also on the moon, and then we start looking for another planet to go on. This is not a good idea. We should be more sustainable. So look for such, what are the challenges in the space right now? What are we looking for? So space debris is also a very big challenge. Then we have this develop research possible solutions. That is for everyone. And then develop the mission concept. Tomorrow is a very interesting session that you are going to have, because I'm going to show you how your team can start working straight away on developing the proposal for your space folio. Then we have this thing, algorithmic computational design. For that, we need to choose an objective. Now, for example, when I say objective, there are many types of objectives. Either you can go with, you can choose kangaroo and there's in grasshopper. This is especially for those who are aware of rhino and grasshopper, who has some background knowledge into that. You can also use kangaroo and see how will inflatable structure will be deployed, how would you perform the simulation. Then there is also for the folding of the panels. Objective can also be a interior element of a space architectural habitat. For example, it can be even a chair, a foldable chair for the space, any foldable furniture, any volume, any exterior design, any parametric simulation, and things like that. It depends totally upon you, but it should have some relevance towards space architecture. You can have an object, you can have a shell, you can have a fabric, you can have a material. It is totally up to you. The purpose of having this is for me to understand that how are you going to use your skills into something like this for the space. Then we have submission requirements. Basically, you have to see, we have very short on time and we don't want to do minimalism is best. We don't want you to put like 2,000 of things or 500 or 50 of things, like small here and there, and there is no clear picture of what is happening. Even if you are able to put one good picture on your whole portrait and able to explain your idea in 10 minutes, I am happy. So quality over quantity, and go with minimalism, because that will help you to save time and to give more quality output of the work. Then we have this thing. These are just some requirements, or you can also go with a portrait or a square shape poster. Don't go with the landscape. Then you can have this width, this height, the file size. You can have 2 minimum renders. You can even have 1, even though we have mentioned 2 minimum, but you can even have 1 if you're able to come up with a 1 good quality. Then you have the design process diagram. This is extremely important. Your conceptual sketches. See, the purpose of this, to understand how are you approaching such a project like that you have never been working before. So even if you are sketching something, like it can be even a bad sketch, but a bad sketch on a piece of a paper, and if you scan it and if you show in your presentation, that also wins us, because that will also help us to understand the process. Because at our design studio, this space architecture course that we are conducting with NASA India, which you are a part of, it is not something that we have copied from somewhere, or we are grabbing the information from the Google and coming up with it. No, this is our internal thing that we are trying to put it out, because I want to create opportunities for the people who are not coming from the space background to have a chance to pick into this industry and do something in it. Because I was one of those, our teammates are one of those, and I want everyone to have this opportunity to be a part of such a booming industry, such a vast industry, such a advanced, because we as humans, we are not here to eat and sleep. We are not animals. Animals does that. We are social animals. We are the intelligent ones. We are so advanced. Our brains are so advanced. Why not push it to what we can do? Why not advance ourselves? Why not thrive for our life? So thriving is very important. And your design thinking will help me to evaluate how much you are thriving for your life, to create that change, to get that opportunity, to bring that evolution. That is very, very crucial. So you don't need, I really don't care how good is your sketch, how is your output presentation, but all I care is how you have approached. Then we have this thing, it is optional, but you may add it if you think you have time and you can come up with something really good, how much you can fit it. You can have a conceptual plan view. You can have also some sort of an analysis, what material are you going to use for your structure, because materials plays a very crucial role, because materials define the cost of the habitat, the durability of the habitat, the lifespan of the habitat, the repairability, maintenance, everything for the habitat. And it is the material which will help you to design how much radiation you will tackle. Like, it is different from space to moon and to the Mars. There is certain radiation. So there is also thermal conductivity, pressure difference. All of these things helps to decide a material. So you can even go with some material if you want to put some more investment into your time. And then you can, when you are designing, you can also when you are taking the subject number 4, which is this one, the computation design one, then you can even present your algorithm. So basically the step-by-step, how you approach to this simulation, what was your process, what were your steps, how come you come to this conclusion. And basically in the 8th and the 9th session, you have around 10 minutes. Every team of 3 would have 10 minutes. And I personally want to see everyone's participation into speaking, even if you're camera shy. I don't care what language you want to conduct your presentation. I would prefer English. But if you're not comfortable speaking in English, if you're not a good speaker, I am not going to judge at all. I'm just going to see that you are here and you presented the work that you have done. And you should be very proud on that day. I'll tell you a secret of, I have a very personal, this motivation. Anytime when I feel lack of motivation, we all do at times. And when I feel, oh, how will this happen? How will I do it? Is it even possible? Because when we are working in the space sector, there are like thousands of failures. There is never one perfect design. even for us, it will take us like 8 to 10 years to come with one successful structure that can literally go in the space. So it is error and trial. And in that moment, I think that whenever my thing is ready, I should be proud of that. I should not think that, oh, I wish I would have worked out or I wish I would have done that. And that is why I enjoy the process. Be very proud of what you will give on that day and let it be. We are all here to learn. So that is all about the space folio. And I already explained that here is the team. There is one more thing that I want to share with you is when we go to reference materials and when we go to the concept diagram, we have just put some reference images. I believe that all of you by now would have at least done this thing. How are you coming to the end design of a project? Like this is like a must thing. And this is very much important for all of you to put your diagrams. It doesn't have to be perfect again, but it has to be understandable. Okay, so are we all clear by now? Then I can explain something more what we're going to talk about in tomorrow's session, or should I take questions? Maybe I can take Q&A. Maybe there are so many. You can raise your hand and start with Q&A if you have. No Q&A. Okay, there is one. Yes. Melissa, start. I see you first and then Abhinav.
Yeah, so good evening, Miss. My question was like, you see, like 4 projects. So are they being proposed by someone, like the problems or the area is being proposed by someone, or is it just an hypothetical thinking of your project?
Sorry, can you please repeat yourself? I lost you.
So like my question is like, the areas that you have chosen in your projects, are they hypothetical or are they proposed to you by someone to think about?
Areas as in like the types of project that we have chosen?
Yes.
At ACA?
Yes.
No, that is what we have chosen. It was not proposed to someone. But while I was working on our projects, we realized that it is so important to first build such projects which will help the current problems. For example, the space debris one, the lunar one. So we have ourselves selected the projects. But what you see on the web is 10% of what we do. Because in the space sector, you have to keep a lot of things private.
So I really need to acknowledge the problems that you have actually come out on your own. When it is proposed, it is more easier than to actually find out a sector on your own.
Yes. Thank you. Okay, maybe Abhinav, you can go next.
In the computational design part, what exactly is the thing that are computed? Like, could you give a few examples? Like,
yes. Okay. Maybe let me show something what I meant over there. 1 second, I will look something for you. Okay, see, I'm going to share my screen. This is a very basic example. I don't know how much in the team. Well, while we were selecting some students, we saw that some people had Rhino Grasshopper very strong skills. So we thought, why not have this also put it as a part of this space folio? And so I am not aware how advanced everyone has a skill. So we went with a very basic simulations. For example, this is a kangaroo extension, which is very useful, especially in the space projects. It helps you to determine the folding and unfolding. For example, this is in Rhino, you can literally inflate this structure and you can see how does that looks like. Or you can also do a lot of, for example, this one. So you can perform animations on how high it will go if we increase the width of the fabric. So this will help you in the volume calculations. So basically it depends upon you to try your best Grasshopper Rhino skills and go with something. You can even have your folding chair. Like you design a chair in a Rhino and then you do some Grasshopper coding on how you are going to deploy a chair in space. So it is a very basic level. but it depends totally upon your skill on how well you are able to cope up with it. If you want to have more detail into that, then I can sit one-on-one with you later on while you form a team with your team and help to evaluate on what will be the best possible. Okay. I think I had one more, but I don't see that person on my screen now.
Yeah, I had a question. I was just wondering if there was like a forum with listing of all these, like you gave an example of the space debris collection sort of module. So if there is a listing somewhere where of things and problems that exists and that we can solve and maybe discuss maybe. Yeah.
If I'm going to give you everything.
No. Just a forum for help, maybe. NASA, like, does NASA have a forum like that? I was just.
Yes, it has.
Oh, yeah. Okay, cool.
It has a forum like that, and just type on Google space debris problems, and you will come up with like more than 1,000 resources for that. So I will tell you something. Why space debris is a very big challenge, and even though space is very big, okay? But why space debris is a big challenge? Because even a small particle, if it hits an International Space Station, it can literally deviate. So that is why these all small things are very crucial. So you can, I think there are also companies who has proposed various solutions to it. You can look in depth and see if you really want to go with a very research project with that. You join our training, okay? Our 6-month training, in that we are doing this thing only.
If I might say, Asta, so to your question, you might find some answers in the sources that we provided.
Yes.
Just saying.
Okay, so I think that is all. Or should I wait for a little bit more? Guys, don't feel shy, ask your questions out. Because we are on one-on-one for how many days? I have to bear you with until 13th of February. There are many days to go with you. So you can ask question if you have. Okay, at least someone can give you a review of how does this session look like. Was it interesting or was it boring? How many of you slept during the session? I'm very curious. Okay, I think no one was sleeping.
It was very interesting, especially the excitement with which you presented it. Even we got pretty excited listening to everything. And
in the coming sessions, we are going to go in a lot of depth, and it will be enjoying that a lot. Okay, Darwin, tell me your question. I see you have raised a hand.
Yeah, thank you, ma'am. Firstly, I'd like to say that it was a wonderful session and it was very intriguing. So my question is that now as we are given a few options of sites like on Moon or Mars or under the water and like such extreme sites on the planet, so we currently aren't completely aware about what conditions this site may have. So I'm personally a bit confused. What shall we go with?
Okay, so we should start with the possible future landing site. Maybe let me just show you something. Wait, I can just do something very quick for you. Let's go here and maybe I will type. Okay, NASA has started this Artemis mission. I really suggest to look for the Artemis mission. Now you see, this is the site on the moon where in July 1969 we landed first time. You will come across so many options because it is just not NASA, but there are various space agencies who are trying to land on the moon in the coming year and this year. Okay, there are, as I mentioned, there are 9 countries who are going to make a landing on the moon. UAE, even Gaganyaan mission, they are also going to see a site where they are going to land our Indian astronauts. So when you find 4 or 5 names of the site, you will find many, but if you find 4 or 5, then you look why they selected this site. What was there on that site? How you will find, because it is not just possible to select for anyone, for example, ISRO to select a site like that. They will have a reason, very valid research done for years to select a site. So you will find a lot of reference material. Oh, maybe there was a water nearby, or maybe there was this nearby. But when you select the site, at the same time, you should also be considered on what is your habitat going to be performed. Like, is the astronaut going to outside of the habitat or not? Are you going to stay inside of the habitat? For how long? What they will need. Now, for example, let's say that we go to the moon for 2 months. For 2 months, we would have all the resources. We will have enough water, everything into our space model. Everything will be recycled. Good. But if we go for 1 year, then we need to go with the biological system. We need to produce a biological system over there. So then what do we need? So that is when the site plays a very crucial role. I suggest that if you're not planning on to starting a very depth project, and if you're planning on to just, get to a conceptual phase, which we are aiming, because after this course, I think you will have an opportunity to continue a project through our mentorship. It is we will voluntary help, because we want to, my purpose is not to dig a name or do something like that. My purpose is for everyone to grow in their career. That is my personal motivation. I want to help and support as much as I can. So you can come to me anytime if you want to go for a long-term project like that. But for now, you can just select which is already existing and which other space agencies are going to select. So it will help you to ease down your load. Because then you will also have to develop the whole concept and everything. So, but you start like that, and then you look why they selected that. Helps? Okay. Yes, Melissa.
So like I just said that it's a very good thing you're finding out problems on your own. How do you all actually go about finding problems? And then how do you all further break down the entire process?
And that's when we do the start. First, we identify the problem. Then we start defining the problem, what exactly the problem is. Then you find like 10 different solutions to a problem. Maybe we can do this, we can do that, we can do that. And then you evaluate all of the problems through design and mission analysis. So from tomorrow, we will start on to this thing. Now tomorrow, let me give you a glimpse of what is going to happen tomorrow. And by the way, is only Dharmik, Abhinav, Ayush and Melissa are in the sessions? I think we are 55 students. Why there are only 4 people speaking up? And I think Dhawal is smiling, but I don't see him speaking anything. And I can only see very few people on my screen, unfortunately. But from tomorrow, I'm going to pick names and I'm going to ask you guys questions if I don't see participation. Okay, let me give you a glimpse for tomorrow. When we go to the support material and we go to, I think, reference material, no, space folder. So from tomorrow,